Hello and greetings to the Dr. Johari. Before I start our presentation, let me introduce myself. My name is Muhammad Ekmal Hakimi, and this is our team member, which is Muhammad Rabani, Jesse Cornelius, and Muhammad Ruzaini, and we are from Group 6. So today we are presenting our this project, which is uh, the title of this project is Programming Calculator. For this slide, I will explain about purpose of the project. Our project is to build an efficient, lightweight command line interface programmer's calculator using assembly language, capable of performing number system conversions, binary, decimal, hexadecimal, and Boolean operation, which is AND operation, OR operation, XOR operation, and NOT operation, that providing a critical tool for programmers and enhancing our understanding of assembly language. Here are some of the purpose of the project, which is the necessity of a programmer's calculator. Programmers frequently work with different number systems such as binary, decimal, and hexadecimal. Converting between these number systems manually can be time-consuming and error-prone. A programmer calculator simplifies this process by providing built-in function or algorithm that can convert number accurately and efficiently. It can be eliminate the need for manual calculations, saving time and reducing the risk of errors. The second point is conversion between number system. The implementation of number system conversion in our programmer's calculator involve creating algorithms or function that can convert number between binary, decimal, and hexadecimal. The conversion process typically includes identifying the input number system, validating the input number, performing the necessary calculations, and produce the converted output. For example, to convert the decimal to binary, the algorithm will divide it by 2 repeatedly and keeping track of the reminders. The last point is implementation of Boolean operations. The implementation of Boolean operations in our programmer's calculator, it requires creating functions or algorithm that can perform logical calculations such as AND operation, OR operation, XOR operation, and NOT operations. For instance, implementing the AND operation involve comparing the corresponding bits of two binary numbers and setting the result of one only if both input bits are 1. For this slide, I will explain about calculator design. Here are some point of the calculator design, which is the first point is high-level design. The calculator's design include distinct efficient modules for parsing user input, performing conversions and Boolean operations, and generating outputs. Means that by dividing the calculator's functionality into distinct modules, the design promotes modularity, reusability, and maintainability. Each module focuses on a specific task, allowing for easier debugging and testing. The efficient design enables a user to perform conversion and Boolean operation accurately, while also providing user clear and concise output. It's very important to note that the actual implementation of these modules may vary depending on the specific programming language. The second point is assembly language. We choose assembly language for its direct hardware control and speed, providing an insightful learning experience about low-level programming. While assembly language programming may be more complex and time-consuming compared to higher-level language, the benefit it provides align perfectly with our project goals. By concept, by utilizing assembly language, we can build the uh, efficient and lightweight programmer's calculator that offers superior performance depends our understanding of low-level programming language. The third point is Boolean operation implementation. We can be implemented Boolean operations such as AND, OR, XOR, and NOT operation using the bitwise operation features of assembly language. By utilizing this bitwise operation provided by the assembly language, we can perform Boolean operation effectively and accurately. These operations are essential for programmers when working with binary data, flags, and logical conditions. And the last point is conversion implementation. Dedicated assembly routines handle the conversion between decimal, binary, and hexadecimal system efficiently. By dedicating specific assembly routines for each conversion, we can optimize the efficiency of the calculations. Assembly language allow us to have fine-grained control over the operations and memory, resulting in faster and more streamlined conversions between number systems. These conversion routines in our programmer's calculator provide programmers with a and convenient tool to convert numbers between different systems effortlessly, whether they need to convert decimal numbers to binary for bitwise operations. Uh, our calculator enables efficient and accurate conversions to faster interpret for easier interpretation. And that's all. Thank you.
Hi, my name is Cornelius. As for my part, I would like to tell you about proceed to a design of the calculator as in sections. There are three parts of sections: data sections, text sections, and business sections. Uh, First things first. In data sections, this sections is used to store initial data including matches, prompts, and result. As you can see in each of our design of the calculator in data sections, such as welcome programming, like programming calculator, a selection of options, which is a number of conversion and Boolean operations. Uh, as for text sections, that is text sections, these sections contains the actual code instructions of the program, including input validations, calculator executions, and result display. It's like a where or assembly and linking, where the assembler converts the assembly language instruction in the text sections into machine code, and with the link combines the text section with the other sections and libraries to create the final executable files. And for the last section is and BSS sections. This section is used to store uninitialized data. It can be simplified programming tasks and optimize the memory usage. As for the next slide, uh, I would like to, I would talk about the calculator functions. As for the functions of the calculator as in assembly language, it provides essential functions such as conversion between number system and executing Boolean operations, making versatile tools for programmers. Alright, we start with conversions. Unit conversions. There are, there are common types of conversions, such as numeric conversions, unique conversions, and time conversions. It illustrates the ease and convenience of using the calculators for quick and accurate conversions. We move on to the Boolean operations. Boolean operations, it introduces logical operators that is AND, OR, NOT, and XOR, and also and bitwise operation that manipulate individual bits. These operations are used in programming and problem solving, such as checking conditions, manipulate flags, and performing data masking. Now we focus to the calculator user interface. Interactions. It explains the input-output capabilities of the calculator, including the keypad, display, and any additional input methods. For example, user can interact with the calculator by inputting the values, selecting the function, and viewing result. By following this structure, you can effectively present the calculator functions of the programming calculator, specifically focusing on the conversions, Boolean operations, and user interaction while keeping the audience engaged and informed. That's all for my part. Now I would like to hand over the next slide to the next presenter. Thank you.
Hi, my name is Muhammad Rabani and I will explain on how to use our calculator effectively. Operating our calculator program are very straightforward. It requiring user to input specific command and their data of interest into this user-friendly command interface. As you can see in the screenshot on the left of the slide, this is the first CLI that you will see when you execute the program. It will ask the user to select between 1 to 2 and 0. The first choice is number conversion, which will direct the user to the conversion CLI. The second choice is the Boolean operation, which will direct the user to the Boolean CLI. And the last choice, which is 0, that will exit the program. Now let's look at the screenshot on the right side of the slide. This CLI is from the first choice, number conversion. In this CLI, there are 6 choices that the user need to choose from, with 0 for the exit program. The second choice is decimal to binary, the first choice is decimal to hexadecimal, third choice is binary to decimal, fourth choice is binary to hexadecimal, fifth choice is hexadecimal to decimal, sixth choice is hexadecimal to binary. For our example, we choose the first choice, decimal to binary. After input 1 and press enter, the user need to enter a decimal number and the program will output the answer which shown in the screenshot on the right side of the slide. In the next slide, I will explain about the second choice, the Boolean operation. There are 4 choices that user need to choose from, with 0 for the exit program. First choice is AND, second choice is OR, third choice is SOR, and fourth choice is NOT. The user need to enter their Boolean operation choices. After that, the user need to input twice for the first and second input, except for the not Boolean. The user need to input only one input. After that, the program will produce the answer. In this slide, we have included the example of screenshot of how all 4 of them will produce the output. That is all for my explanation on how to use the calculator program. I will pass to our next and last presenter, Mr. Ruzaini. Thank you.
Ladies and gentlemen, today I want to share our journey of creating a calculator and overcoming challenge along the way. We learned a lot of programming and problem solving. Our first challenge was designing a user-friendly interface. We wanted to use our calculator to be easy to use, but it was harder than we expected. We spent time and effort making it simple and effective for everyone. Next, we had to learn assembly language, which was quite tricky. It's a low-level programming language with a lot of details to understand. We study hard and practice a lot to get better at it. Implementing the calculator's functions was also challenging. We had to figure out how to make it do calculations and handle different operations. It required us to be creative and persistent in finding solutions. Through this project, we learned a lot. We improved our programming skills and problem-solving abilities. Most importantly, we learned the importance of not giving up when faced with tough tasks. We kept doing even when things got difficult. In conclusions, this project taught us valuable lessons. We overcame the challenges of designing a user-friendly interface, learning assembly languages, and implementing the calculator function. It wasn't always easy, but we never gave up. All good things always come to an end. Thank you for your time and attention today. We hope our journey was inspired you to face challenge and keep learning. Thank you once again and best wishes in our own endeavors. Thank you. Ladies and gentlemen, today I want to share our journey of creating a calculator and overcoming challenge. Along the way, we learned a lot of programming and problem solving. Our first challenge was designing a user-friendly interface. We wanted our calculator to be easy to use, but it was harder than we expected. We spent time and effort making it simple and effective for everyone. Next, we had to learn assembly languages, which was quite tricky. It's a low-level programming language with a lot of details to understand. We studied hard and practiced a lot to get better at it. Implementing the calculator's function was also challenging. We had to figure out how to make it do calculations and handle different operations. It required us to be creative and persistent in finding solutions. Throughout this project, we learned a lot. We improved our programming skills and problem-solving abilities. Most importantly, we learned the importance of not giving up when faced with tough tasks. We kept going even when things got difficult. In the conclusions, this project taught us valuable lessons. We overcame the challenge was designing a user-friendly interface, learning an assembly language, and implementing the calculator's functions. It wasn't always easy, but we never give up. All good things always come to an end. I thank you for your time and attention today. We hope our journey was inspired you to face challenge and keep learning. Thank you once again and best wishes in our endeavors. Thank you.